Good. So, IBM, you said this, I think, at our dinner on Monday. Yeah. You're probably one of the few people who went from a business department to a research department. Usually it's the other way around. So what led you to this step?
I thought I would take a job at IBM. As you may know what a systems engineer is, this is the one who does the technical work for the salesman, but the salesman is the one who is the bigger one, okay? And I'm the helper, and I didn't like this, yeah, after a while. So, are we already here?
Yeah, so you switched to the research department?
And yeah, switching to the research department. First, during the time when I have been systems engineer at IBM, I got interested in, I said it yesterday, in optimization, for example, as a systems engineer, I had also some real technical problems, I must say. Yeah? For example, there was a hydroelectric dam and they had collected data and I had to fit by a regression analysis a model to how this wall moves independent of height of water, etc. But what I also did is I started by chance. I came across multi-stage decision processes. And in this connection I came across dynamic programming, and particularly I liked Pontryaghin's maximum principle for optimum control. I was always fond of thinking about dynamic systems, okay? And that actually laid my foundation for the dissertation, which I then later wrote at IBM.
So you wrote a dissertation, and this was a different time from nowadays, and in particular...
Okay, maybe we have now a disconnect. So one day I said to my manager, this is fine and good, but I think I'm in the wrong career path, and I would like to work as an electrical engineer. And I was actually already interviewing with companies, particularly in Germany. And they said, look, IBM has laboratories, why don't you go there and look around? And they sent me on a tour. And so I came to the IBM research lab also. And the environment looked great. There was a nice big lake, Zurich Lake, also mountains, etc. Ideal environment. And I went there I didn't have a PhD, okay? And I went there, initially I think the others thought, here's coming some guy who is helping us with programming in a speech processing project. All right, but it was clear that I had to go for a PhD. I had this knowledge about dynamic programming, other optimization techniques. I looked around where it would be in communications, because I was in a communication department in this research. Where is a problem where this could be used? And that was that led to my dissertation on nonlinear equalization of binary signal in partial in Gaussian noise. And how did I do this? I had this work in the speech processing group. I think this was not scientific enough. And I had to do something else, which was more scientific, more mathematics oriented, and so I found my dissertation subject, and actually I worked it out in a few evenings. I had the math for it, and I had written it up also in less than certainly less than half a year. The dissertation was finished. I got some help to find a professor at ETH Zurich and a co-referent also. And the problem was only that I was not the normal PhD student. I was working in the IBM lab, and what bothered them mostly was that it came so quick, because I had already said, here's my dissertation. The one professor agreed with it. All right, and then ETH Zurich said, okay, but you have to be inscribed for 2 semesters, do some courses, attend some courses, and do 2 semester works, which I did, okay, and then I handed over the dissertation, and that was it.
Very different from how it's done nowadays.
Yeah.
So there's one thing that you said that I would like to distill and see if you agree with it. So you found a beautiful mathematical concept that you wanted to apply to something, and then later you found the problem to apply.
Well, I understood the general techniques of doing such multi-stage decisions. Think of the Viterbi algorithm.
Your first paper, what made you decide that you would like to publish your results? I mean, this was being in industry at the time, I guess, not as widely done maybe, or at least in that part of the world.
Well, I was in a research lab, industry research lab, and going for publication was desired, that people would publish something, but there was not nearly a pressure like in the academic world. So I wrote this up, and what happened then? I submitted it, okay, got good reviews, etc. I got a letter from David Forney. Who knows David Forney? Some, okay. I think it was a handwritten letter, and he wrote to me, sorry, I had just finished, and it's already in print, his paper on the Viterbi algorithm. I would have included your paper as a reference, but it's too late. And by the way, you have found the bidirectional sum product algorithm, the BCG algorithm, later published in '74 by the BCH guys. Okay, but in a simple form, only for binary signals, and in the simple interference case. And I had also, what did he say? The min sum approximation of it, but I missed the Viterbi algorithm, an algorithm which advances in one direction of time, not this, okay? Now, of course, then everything was clear to me, and I was absolutely fluent in maximum likelihood sequence detection. And I believe we may perhaps go on here. Right, the lab, what is this?
The beautiful lake that you mentioned. And your work at IBM. So I think many people here know that Gottfried is also a very hands-on person. And I'm not sure many of you know that he built and developed his own digital signal processor, including computer architecture and everything from scratch.
Well, so I thought about the applications, and it was pretty clear where the applications are, namely in magnetic recording and in voice-band modems at this time. Okay? in magnetic recording, if you do partial response class 4 at this time, shaping of the read signal, okay, and then a very simple Viterbi algorithm can be used to decode. And it was initially difficult to convince somebody in the IBM development labs to adopt this for magnetic recording. At this time they did peak detection, they tweaked capacitor values and so on in order to, when there was a transition, that you see a nice peak. It was rather unscientific. The main lab doing this, I couldn't have an intellectual connect with them, but with others. And eventually, and actually we built in Zurich a prototype for a group in England, IBM UK. Well, this did then not work out, but finally it was adopted by an IBM laboratory in Rochester, Minnesota. They saw this, they said, okay, clear, it took it. But from the first idea that this should now be used in magnetic recording to when the first products came out, spanned a time of 10 years, or a little more than that. In voice-band modems, the development lab responsible for this was in Lagode, France, at the Côte d'Azur. And I went there also, and I did simulations, etc., to apply for uncoded modulation with intersymbol interference, maximum likelihood sequence detection, which I called at this time still nonlinear equalization, but the gain was small compared to linear equalization. And should I repeat what I said yesterday in my talk?
No, I think what maybe...
Information theory then showed the way. You need to find something with larger Euclidean distance. You saw these little examples, which I did in yesterday, showed you yesterday. And from there went on, and that led to trellis-coded modulation.
And maybe here what would be interesting, is that as young researchers, I'm no longer young researchers, or young researchers often think, what was the spark for this idea? How did this person think differently? So rather than focusing on the technical specifics of trellis-coded modulation, do you remember one moment where you understood, okay, this is exactly what should be done, and it was so different from everything else that had been done until then? Did you have a Eureka moment?
I tell you what helped also, that I didn't know much about error correction coding, right? I started from ground off. Okay, you need to have large Euclidean distance and decode with maximum likelihood sequence detection, okay? And only afterwards, I then began to understand the whole field of error correction coding. So not knowing about, or not knowing much about the error correction coding at this time was helpful. But you mentioned signal processes. The paper, the 1982 paper, which many of you know, I wrote in 1978, okay? I actually submitted it, it got good reviews, some changes should be made, but I had the idea of implementing modems and maybe being the first one who has trellis-coded modulation in them. And so I started to develop digital signal processes from scratch, RISC architecture, very efficient, overlapping everything that does some computing or a function, yeah, in every cycle used. Okay. And well, the director of the IBM Research Lab in Zurich, Carsten Drangheit, was very helpful to me. Yeah? And he said, okay, you're free, no longer speech processing, show what you can do. Yeah? And he gave me the technician. So we started then also to implement digital signal processor, a first one, called SP12, yeah, and then later an SP16. Well, and then people joined, yeah, and the group grew. But when the first voiceband modem with trellis-coded moderation was actually running, the group was 4 people, okay, at this time. Yeah. And all this consumed a lot of time in the lab, finding problems. If you build yourself a signal processor and then you crank up the instruction rate, then somewhere it fails. Okay, where does it fail? Yeah? A lot of work with logic state analyzer, scopes, etc. Yeah? And so the publication of this 1982 paper got delayed. Yeah?
But then TCM made it very quickly into standards. Were you part of the standardization, or was this done by other people? How did that happen? Again, Dave Forney comes into the picture here. Dave Forney attended the ITU meetings for voiceband modems. I was not yet part there. Yeah? And the AT&T people, they tried to do something, and Dave Forney told them, okay, look, here's this paper that we should do. Yeah? And then I also joined the ITU meetings on voiceband modems, and trellis-coded modulation was adopted in no time. So, after IBM, or what made you decide to change or to seek new challenges? You left IBM in 1998, if I remember correctly.
Yeah.
Yes.
Well, I was in a, from the position point of view, in IBM in a good position. I was an IBM fellow. But I wasn't too happy with my environment, and I began to realize that IBM would probably not become a well-known, a strong company in communications. Okay. Although there were good people, not only in research but also in development, particularly I thought in Lagode laboratory in France. For example, they had the first fully electronic PBX, yeah? Came from IBM and so on, but the management of IBM was not educated, didn't know much about, well, first the technology, in any case, for communications, but also not how to market products in this area. And this went on over the years, and I developed more and more a feeling that IBM would not be successful in communications. And so I left.
So at Broadcom, you started being interested in fiber optic communication, is that correct?
No, at Broadcom, I started first in cable modem. No, actually I had already started in IBM also to have an effort in cable modems. In Broadcom I worked then on cable modems initially, then DSL, then what came after this? Something in advanced coding for fiber, optical channels. I had always to deal with things where things became a little mathematical and a little advanced, and it looked at many things there. I had one longer-term project at Broadcom. This was this 10 GPST 10 gigabit transmission over twisted pair cables. There I participated extensively in the IEEE standards development for that. Later on I did also other things. And by the way, I worked in my whole life more on algebraic coding than things like trellis-coded modulation. So what do we have here?
So in the age of lots of paper writing, which is a very different age from the age that you grew up in scientifically, young researchers often ask themselves, should I write more papers to satisfy metrics and criteria to move ahead in my career, or should I be interested in producing a few gold nuggets that I will be remembered for? And of course there are practical constraints and so on. But going back to your work, what are the three main contributions that you most liked and that you think back to with the biggest delight?
Well, of course, I liked everything that had to do with maximum likelihood sequence decoding and then particularly known as trellis-coded modulation. But I at least liked as much adaptive equalization. Okay, and shortly after, actually before the trellis-coded modulation paper, I wrote a paper on what was this? This is not exact. The convergence behavior of adaptive equalizers. Okay, using the LMS algorithm, and I believe I could say I was the first one who correctly analyzed the convergence process. Unfortunately, in IBM, they said you have to publish this in the IBM Journal of Research and Development, and there not many people did see this. Okay, so adaptive equalization I liked very much, and I implemented also a lot of it. Actually, I implemented most of the things I worked on. I liked also the work on synchronization, rigorously from the maximum likelihood point of view, and I did not publish. And I liked also the work on algebraic coding, and there's also some work that I have not published that is in connection with burst error correction, where multiple Reed-Solomon code words are decoded at once. Well, maybe I should be more clear. A common error locator polynomial is determined for multiple code words. Then you have more equations on the error locations. And you can decode beyond half of the free distance, the minimum distance. And well, this I liked also a lot. Product codes I liked. I didn't publish maybe at least No, not more than maybe half of what I've done.
Well, publishing was difficult because you had to run a group at IBM, I understand.
Yes, this was a burden, because I had also people responsibility. And here you see some result of later years. By the way, this is my wife. I met her.
No, that's the next slide. So this is here.
This is the next. Okay, this is my wife. Yeah, I met her at this little lake. Yeah, let's go back to the other one.
You will tell us later how you met her.
Okay. With what should I start here?
Maybe top right picture.
Okay. At some time, okay, then I did the permit for coastal navigation, or no, well, to sail around in the Mediterranean or everywhere, and so. I went with two crews. Yeah. One was with my elder brother and friends and so on, and the other one was the information theory crew.
Part of which is present in this room.
Yeah. Okay. I see. How many did you say? Dick, Barbara. Yeah, two are present. Okay.
Please make sure to talk to them
later. We did over a span of 20 years about. Yeah, I went met with my wife and with children. Initially we went my wife and children. Yeah, okay, and then with my brother and so on. But then also with the friends from information theory. And okay, so I had this license for navigation on the sea, and during a period of about 20 years, we always went somewhere on the ocean and to sail around from mostly in Mediterranean, but also Caribbean, Maine once, yeah. Okay. And now to this picture, okay. On the right, yeah, what do you see? And who are the people? On the, let me see, rightmost is Dave Forney, then left from him behind his son, below my wife, in the middle am I, behind is Barbara Playhood. You see also Dick Playhood and Liz Massey, and Jim Massey took the picture. Okay. Let me tell you about this. This was the first time that I went with these guys on a sailing cruise. And we got out of the harbor in a few nautical miles, and they all disappeared on the deck, and came out with these T-shirts. Everyone had captain on it. Dick, however, had it with a misspelling, but this is not visible here. Okay, and he handed over to me the T-shirt with crew. Was very distressing, okay. And they demanded to take over the helm, and I gave it to them, and they ran on a sandbar. And that was then their lesson, okay.
You should mention this was a 2-week trip in the Ionian Sea.
Sorry?
You should mention it's a 2-week trip in the Ionian Sea.
A 2-week trip in the Ionian Sea. It was a 2-week trip.
Yeah, 2 weeks in the Ionian Sea, out of Corfu, down south, Gulf of Corinth.
And on the last day, you got a cat.
Okay, what else do we have here?
I just want to make sure, please make sure to talk to Professor Playhood and his wife Barbara later to hear more stories about the sailing trip. I can tell you there are infinitely many of them, and they're infinitely interesting. Good. So your wife, Sony, you met her on the water.
Yeah.
You mentioned.
Well, at the lake.
So when was that? How did it happen?
Well, I think I met her first maybe at the age of 16. Yeah. Right.
I don't know. I was not born at the time, so how would I know?
No, because there was a different date here. Okay, so it was maybe 1957.
I know the lake. Yeah. I've been there, but obviously post 1970. So.
Yeah. Okay.
Good. Your family. The top picture shows you with the two daughters.
Okay. This
Andrea and Iris.
On the right is Andrea. Andrea, stand up. She has grown a bit, right? Okay, on the left is Iris. And this is somewhere in Switzerland. Okay, now the grandchildren. Yeah. Okay, each of the two daughters has 3 children, and on the left side, these are the children of Andrea, and on the other side are the children of Iris. And where is Selina? Selina. Okay, the daughter of Andrea. Okay, this is Selina. Took away from me the information theory book, and very interested and studies it.
So I have a statement.
Truth is that I made it up with her.
I have a statement here from your daughter Andrea, who just stood up, that you're not allowed to look at this. I'm going to read this now.
Okay, good.
Okay.
I see.
To conclude, I would describe my father as a typical man of research, who is very straight in his thoughts of what he is working at, but he's also very interested in many other subjects. For me as a child, and even now as a grown-up daughter, it was and is always fascinating what he knows, what he can, in intellectual as in manual-wise, and what he still wants to do. He is very strong in different ways, but everything has its time. Do not mix things up, one thing after the other. But one issue always was, and is extremely important, the family. Besides everything he has done, he always had time for us, my mother, my sister and me, and even now with his grandchildren, he finds the time to give them advice or helps, even when they're not always wanted. Wasn't it the same with us? He showed us a wonderful life in different shades and led us, certainly in cooperation with our mother, to become very content, self-confident and happy people. For all this, I would like to say thank you to him.